Are they a copy of our galaxy? The concept of a galaxy outside of our universe being a copy of ours is highly speculative and not supported by current scientific understanding. Our universe is defined as the entirety of all matter, energy, and space-time that we can observe and interact with. It encompasses an immense range of galaxies, stars, planets, and other celestial objects. However, the notion of parallel universes or multiple universes suggests the existence of other realms or domains that may have different physical laws, properties, and configurations. These parallel universes are not necessarily copies of our own universe but can have distinct characteristics and arrangements. In some theoretical models, such as the many worlds interpretation of quantum mechanics or certain formulations of the multiverse theory, it is proposed that parallel universes could exist alongside ours, each representing a different outcome or possibility. These parallel universes may have their own galaxies and celestial structures, but they are not considered exact copies of our universe. It is important to emphasize that the concept of parallel universes is still speculative and subject to ongoing scientific investigation. While the existence of parallel universes remains a fascinating area of exploration, the specific nature and properties of these universes, including their galaxies, are still matters of theoretical inquiry rather than established scientific fact. There is a wide variety of galaxies in the universe, each exhibiting unique characteristics and structures. Here are some examples of different types of galaxies. 1. Spiral galaxies. Spiral galaxies, such as the Milky Way, have a distinct spiral structure with a central bulge and arms that extend outward. They often contain a mix of young and old stars and may harbor features like dust lanes and star-forming regions. Spiral galaxies have a distinct appearance characterized by a central bulge surrounded by spiral arms. The spiral arms often have a graceful, swirling pattern that extends outward from the center. These arms contain a mix of stars, interstellar gas, dust, and star-forming regions. In terms of the number of planets in a spiral galaxy, it is difficult to provide an exact count as it can vary greatly from one galaxy to another. However, based on our observations within the Milky Way galaxy, which is a spiral galaxy, it is estimated that there are billions of planets within it. These planets can vary in size, composition, and distance from their parent stars. As for the kind of people living in a spiral galaxy, it is purely speculative at this point. Our current understanding of life in the universe is limited to Earth, and we have yet to discover definitive evidence of extraterrestrial life. Scientists are actively searching for signs of life on other planets and moons within our own galaxy and beyond. However, until concrete evidence is found, the existence and characteristics of beings or civilizations in spiral galaxies remain a subject of speculation and scientific exploration. It is important to note that the vastness of the universe and the diversity of conditions on different planets provide the potential for a wide range of environments and life forms. Speculating on the nature of hypothetical life in other galaxies, including spiral galaxies, involves a significant degree of imagination and remains an active area of scientific investigation. 2. Elliptical galaxies. Elliptical galaxies have a more rounded, elliptical shape and lack the prominent spiral arms seen in spiral galaxies. They tend to have older stars and less ongoing star formation compared to spiral galaxies. Elliptical galaxies are a type of galaxy characterized by their rounded elliptical shape. Unlike spiral galaxies, they do not have the distinct spiral arms or disc-like structure. Instead, they appear as smooth and featureless systems of stars. The appearance of elliptical galaxies can vary in size and elongation. They are classified based on their shape, ranging from nearly spherical E0 to highly elongated E7. The stars within elliptical galaxies are typically older and have a more random distribution compared to the organized patterns seen in spiral galaxies. Regarding the number of planets in elliptical galaxies, it is challenging to provide an exact count as our knowledge of planets outside our own galaxy is limited. Most exoplanet discoveries have been made within the Milky Way, which is a spiral galaxy. However, it is reasonable to assume that elliptical galaxies may also have planets. The existence of planets in other galaxies, including elliptical galaxies, is based on theoretical predictions and extrapolations from our understanding of planet formation and the prevalence of planets in the universe. As for the kind of people living in elliptical galaxies, it is purely speculative at this point. Our current understanding of life in the universe is limited to Earth, and we have yet to discover definitive evidence of extraterrestrial life. It is important to note that the conditions for life as we know it require certain factors, including the presence of liquid water, suitable atmosphere, and other essential ingredients. Speculating on the existence and characteristics of beings or civilizations in elliptical galaxies or any other galaxies beyond our own is highly speculative and falls within the realm of science fiction. The search for extraterrestrial life is an ongoing scientific endeavor, and future discoveries and advancements in technology may provide more insights into the potential existence of life in other galaxies. 3. Irregular galaxies. Irregular galaxies do not have a defined shape and lack the organized structure seen in spiral or elliptical galaxies. They can vary widely in size and may contain both young and old stars. Irregular galaxies are a type of galaxy that lacks a distinct shape or structure. They do not conform to the well-defined spiral or elliptical shapes seen in other types of galaxies. Instead, irregular galaxies appear irregularly shaped, with no specific pattern or symmetry. Irregular galaxies can vary widely in size, ranging from small dwarf irregulars to larger irregulars. They often exhibit a chaotic appearance with clumps, knots, and regions of intense star formation. The stars within irregular galaxies are a mix of young and old stars. Regarding the number of planets in irregular galaxies, it is challenging to provide an exact count as our knowledge of planets in other galaxies is limited. Most exoplanet discoveries have been made within the Milky Way, which is a spiral galaxy. However, it is reasonable to assume that irregular galaxies may also have planets. The existence of planets in other galaxies, including irregular galaxies, is based on theoretical predictions and extrapolations from our understanding of planet formation and the prevalence of planets in the universe. As for the kind of people living in irregular galaxies, it is purely speculative at this point. Our understanding of life in the universe is currently limited to Earth, and we have yet to discover definitive evidence of extraterrestrial life. The conditions for life as we know it require certain factors, including the presence of liquid water, suitable atmosphere, and other essential ingredients. Speculating on the existence and characteristics of beings or civilizations in irregular galaxies or any other galaxies beyond our own is highly speculative and falls within the realm of science fiction. The search for extraterrestrial life continues, and future discoveries and advancements in technology may provide more insights into the potential existence of life in other galaxies. 4. Lenticular galaxies. Lenticular galaxies have a shape that is intermediate between spiral and elliptical galaxies. They have a disc-like structure without the distinct spiral arms found in spiral galaxies. Lenticular galaxies, also known as S0 galaxies, have a shape that is intermediate between spiral and elliptical galaxies. They possess a disc-like structure without the prominent spiral arms found in spiral galaxies. Lenticular galaxies also have a central bulge similar to elliptical galaxies, but they lack the spherical or elongated shape of pure ellipticals. The appearance of lenticular galaxies can vary, but they generally have a smooth and featureless disk with a central bulge. They lack the distinct spiral arms seen in spiral galaxies but may contain a mix of older and younger stars. When it comes to the number of planets in lenticular galaxies, it is difficult to provide an exact count. Most exoplanet discoveries have been made within the Milky Way, which is a spiral galaxy. However, it is reasonable to assume that lenticular galaxies may also have planets. The existence of planets in other galaxies, including lenticular galaxies, is based on theoretical predictions and our understanding of planet formation in a variety of galactic environments. As for the kind of people living in lenticular galaxies, it is purely speculative at this point. Our current understanding of life in the universe is limited to Earth, and we have yet to discover definitive evidence of extraterrestrial life. The conditions necessary for life as we know it, such as the presence of liquid water and suitable environmental conditions, are still being explored and understood. Speculating on the existence and characteristics of beings or civilizations in lenticular galaxies or any other galaxies beyond our own is highly speculative and falls within the realm of science fiction. While the exploration of extraterrestrial life is ongoing, it is important to approach the subject with scientific curiosity and await concrete evidence or discoveries before drawing definitive conclusions. 5. Dwarf galaxies. Dwarf galaxies are smaller and less massive compared to larger galaxies like the Milky Way. They can come in various shapes, including irregular, elliptical, or even dwarf spiral galaxies. Dwarf galaxies are small galaxies that are significantly smaller in size and mass compared to larger galaxies like the Milky Way. They are commonly found as companions or satellites orbiting larger galaxies. Dwarf galaxies come in different types, including dwarf elliptical galaxies, dwarf irregular galaxies, and dwarf spheroidal galaxies. The appearance of dwarf galaxies can vary depending on their type. Dwarf elliptical galaxies typically have a smooth and elongated shape, resembling the elliptical galaxies but on a smaller scale. Dwarf irregular galaxies, on the other hand, have a more irregular and chaotic appearance with clumps, knots, and regions of active star formation. Dwarf spheroidal galaxies are faint and have a round or spherical shape, lacking significant structure. In terms of the number of planets in dwarf galaxies, our knowledge is limited. Most exoplanet discoveries have been made within the Milky Way, and dwarf galaxies are less explored in this regard. However, it is reasonable to assume that dwarf galaxies may also have planets. The existence of planets in other galaxies, including dwarf galaxies, is based on theoretical predictions and our understanding of planet formation in a variety of galactic environments. Regarding the kind of people living in dwarf galaxies, it is purely speculative at this point. Our understanding of life in the universe is currently limited to Earth, and we have yet to discover definitive evidence of extraterrestrial life. Dwarf galaxies, with their different characteristics and environments, may provide unique conditions for the potential emergence of life, but it remains a subject of scientific exploration and discovery. Speculating on the existence and characteristics of beings or civilizations in dwarf galaxies or any other galaxies beyond our own is highly speculative and falls within the realm of science fiction. The search for extraterrestrial life continues, and future advancements in technology and observations may shed more light on the potential existence of life in dwarf galaxies and other cosmic realms. Regarding the existence of living people in other galaxies, it is currently unknown. Our understanding of life in the universe is limited to our own planet. Scientists continue to search for signs of extraterrestrial life, but no conclusive evidence has been found thus far. The possibility of life existing in other galaxies is a subject of ongoing scientific exploration and speculation. However, due to the vast distances and the challenges of interstellar travel, direct contact or interaction with potential extraterrestrial civilizations remains speculative at this point. Can we use wormhole to reach the other galaxies? The concept of using wormholes to travel between galaxies is intriguing and has been popularized in science fiction. However, in our current understanding of physics, the existence and practical use of wormholes remain speculative and theoretical. Wormholes are hypothetical shortcuts or tunnels in spacetime that connect two distant points, potentially allowing for faster-than-light travel or shortcuts across vast cosmic distances. They are often depicted as bridges between different regions of the universe. While the mathematics of general relativity allows for the existence of wormholes, their stability and the ability to traverse them safely pose significant challenges. The main obstacle to using wormholes for intergalactic travel is the requirement of exotic matter with negative energy density to stabilize the wormhole and prevent it from collapsing. Exotic matter, which has negative mass or negative energy, remains purely theoretical, and its existence has not been observed or confirmed. Additionally, the immense energy and technological capabilities needed to create, manipulate, and navigate through a wormhole are far beyond our current scientific understanding and technological capabilities. It is important to note that our knowledge of wormholes is based on theoretical physics and mathematical models. While wormholes are fascinating concepts, they have not been observed or confirmed in the natural universe. Much research and exploration are needed to advance our understanding of wormholes and their potential implications for intergalactic travel. As of now, our methods of exploring and studying other galaxies are limited to observational astronomy, using telescopes and spacecraft to gather data and study distant celestial objects. Traveling to other galaxies, even with the concept of wormholes, remains a topic of speculation and the realm of science fiction.